Hello and welcome to a new video. This is for Matthew C. Zeta, that curriculum, and we are on lesson 28, which is talking about planes and symbols. So this is basically going to add on to last lesson where we talked about points, lines, line segments, and rays. And so now we're going to add to this planes and then just a variety of vocabulary. So this is going to be an incredibly heavy it'll be incredibly heavy on vocabulary, definitely a lot of fill in the blank sort of situations and some matching as well. So first off, what is a plane? That's a great question. So a plane is basically like a flat surface. So where we have lines that basically go left or right or up or down, or like they go in two directions, but like we actually would consider them to be one-dimensional because of the fact that they're only going left and right or up and down and not both of those, whereas a plane goes both of those directions. So planes are two-dimensional spaces that we can put figures or lines or points or whatever on. So I guess a plane is just a flat surface or a two-dimensional space. We're going to talk more about dimensions here in a little bit, so if you're not super aware of what that means, then hopefully we'll work on that. So a two-dimensional space, as opposed to a line, which would not be two-dimensional in and of itself, or as opposed to the world, right? Like the actual, like where we live, which is actually three-dimensional because we have three directions. So plane geometry has to do with geometry of shapes, the shapes that we're used to actually. So we could call it the study of flat two-dimensional shape. So we talked about what geometry is in general last lesson, that it's like, it literally means measurement of the earth. And so it's all these things that come together as we're talking about like properties of lines and measurement and these different things, but shapes is a part of it. So specifically plane geometry is talking about studying two-dimensional shapes. And when you take geometry in high school, there's a lot that you can actually learn about triangles. A lot you can learn about triangles and squares and rectangles and really all the different shapes you know and love from, well, if you're like my child, that you've known since you were like 2 what they are. Not that I have accidentally been biased in my education of him or anything, but that's the kind of thing that we're talking about with plane geometry, as opposed to solid geometry. As opposed to solid geometry, which I don't even know if that's somewhere in the book, but solid geometry would be where we would study three-dimensional shapes. So yeah, so that's kind of the idea there. So now let's talk about dimensions, and this is kind of a tricky topic, or it can be if we try to go past the idea of there being 3 dimensions. But 1 dimension means that we are moving in a single direction, and so that would be something like a line. So 1 dimension are lines or rays or line segments would be one-dimensional. But also it's just the idea that we're only moving in one direction, either left or right or up or down. I was trying to think of a game that would apply here, but even like the side-scrolling games like Mario, where you're moving sideways, you're still able to jump up and down So it's kind of one-dimensional in that, like, your main movement is left or right. That's kind of what I was thinking of. Whereas 2 dimensions would be a situation where you can move in 2 directions. So you can move something or perceive something left and right, and also in an up and down or forwards and backwards situation. So 2 dimensions would be planes. And so we can move 2 directions. 3 dimensions would be, like I said earlier, the world around us that we can move. Yes, we can move left or right. We can move forward or backward, and we can move up or down. Although the up part is kind of difficult, right? Because you have to jump or climb or things like that. But basically, just space. The space we live in is 3 dimensions. So it's this idea that we can move in 3 directions. And so it is an interesting thought to think about, then what would that mean that 4 dimensions looks like, or 5 or 6 or 7. But that's really, really kind of higher level and out there. But could be an interesting conversation. So 0 dimensions would be a point. Because a point does not have length or width. It's just a single location. So 0 dimensions would be that we're just talking about a single location. And that would not be a very interesting place to live or whatever, right? Just being like stuck in one spot and not being able to move. I don't know. Some of the other vocabulary we have here is these 3 words right here, which also we're going to have symbols that go with it, and I should go back up and say that a plane actually has a symbol that we make where it's just, this is going to look not super great. A parallelogram. I wonder if I could, like, there. That's a good parallelogram, right? Although it's facing the other way than what I was going to have mine face. I don't know that that matters, but so a parallelogram like this, which is a fancy word, right, for a rectangle that's a lot of times it's kind of like leaned over a little bit. If you're talking about a plane, you can use this symbol instead of having to write the word plane. Although, you know, we could argue that that's not actually any easier, especially if you're drawing on the computer. But symbols for these 3 words and the ideas here that we have are equal. The symbol for that is an equal sign. And we can say that, like when we say that 2 things are equal, we're talking about numbers specifically. That number, wow. Numbers can be equal. Like 5 equals 5. Right? And then we also can, I guess, extend that to, you know, expressions can be equal, because that's how we end up making equations. So 2x equals 10. Like, those things can be equal. And maybe it's like, well, why are we talking about this? And that's because whenever we're talking about shapes being the same, we use a different word. We use the word congruent. Congruent means same size, same shape. And so that means that if we were able to like measure the sides of the shapes and measure the angles of the shapes, we're going to come up with the exact same measurements for every single angle and side. And that's something actually that in our high school geometry classes we really do a lot with, is talking about how do we know if things are congruent or not. And so the symbol for that is this equals, but with a squiggly line over it. So that is the symbol for congruent. It means same size, same shape. Similar means that, again, we're talking about like shapes. Whenever we talk about things being similar, it means that they're the same shape, but they can be different sizes. Same shape, different sizes. And actually it specifically means that like that one is like the other one, but expanded, like magnified, like if you zoomed in or zoomed out. So it's not just that like they're different sizes and maybe look completely different. It would actually be that we would have to take, like if I take this triangle, wow, that's such a good triangle. Let's see, these two triangles right here, these are congruent. Let's see if this works. So these are similar triangles because they are not the same size, but they do still appear to be like the same shape. They'd have the same angles still if they were similar, actually. The side lengths have grown by a certain amount. So maybe the sides are twice as big or 3 times as big. That's what similar means. Similar, we use just the squiggly line right here to say similar. So we could say like that triangle. This is so weird because now we're kind of getting into things like triangle ABC is similar to triangle DEF. Like that's the kind of thing you'll usually see that symbol with, where we've labeled this triangle ABC and this one DEF. And so we'll say, oh yes, those are that statement you've said there is that they are similar. I totally understand what you mean by that. So that is the vocabulary for this section, and there really isn't much more to it. I want to say, like, if you sat and worked on the lesson like right after watching this, you'd probably I would think that it'd be pretty easy to go through and fill in the different blanks and things like that. And this is just like something we have to do to kind of build our general math knowledge. Like at some point in time later on, like maybe geometry, you know, you're going to take for granted the fact that you know some of these things, that you understand what dimensions are, and that you know what the names of the shapes are, or at least some of them. And so we're starting to build that now, and we'll continue to build on these ideas as we go along. So thanks so much for watching. Hope you enjoyed the video. If you don't mind, give me a thumbs up on the video to show that you liked it and it helps out with YouTube and stuff. And subscribe if you haven't already. And I'll see you in the next video. We're almost done, which is pretty exciting. If you're into that sort of thing, like being done with school. If not, then it's not exciting. Anyway, though, have a great day or night or whenever you're watching this. And thanks. Bye.